This is Brandon Tran, and this is my controller for the line tracker. So I'm just gonna go into detail about how I designed this and stuff. So these are our inputs, and I used 8 LEDs to represent them. So this is a XOR gate under there. It's kind of like not seeable, but essentially I just XOR'd all of them so that I can use this switch to toggle between if the line is black or if the line is white. I then used an OR gate to OR the first three so the three leftmost inputs together to make a input called left, and then the three right inputs to make an input called right, and then these two I ANDed with one of these gates. This is an inverter. This is just an inverter to for the state logic. So these three this LED represents left, middle, and right. They represent the input. So if any of the leftmost three data bits are on, then this will turn on. If both the middle ones are on, this will turn on, since those are ANDed. And if any of the three rightmost are on, then this will turn on. This is just all my state logic. These are 2 AND gates, an OR gate, 3 more AND gates, and that's just my state logic. This is the register, so all the logic goes into there. This is the reset switch, and that goes to this, which is these are 2 inverters. This is to find the speed that the wheels will go at. So the left represents turn this off. The left represents in binary, so this is the most significant bit. So when it's on, since this represents 7, so the speed is going to be 7 when 3 are on, or we can make it 0, so that's when it's going to turn. I'll go into that more later. And these 2 LEDs, or these 4 LEDs, show which speed the wheels are turning at. So right now they're both 7, but these 2 show if it's 0. So if it were to turn left, it would be the right wheel is still at 7 and the left wheel is at 0. Okay, so now let's just do some cases. I just have my inputs connected to ground right now, so that's as if it was not over any line. So now if I take one of the left ones, put it on, now the left will turn on. The left bit will turn on, which means the left wheel has to stop so it can turn left. So this means the right is still at 7 now, and the left is at 0. As we can see, we get the same result for doing any of the left. See, we get same result with the right staying at 7 and the left staying at 0. I mean, changing to 0. So now the same thing goes for the right. So if I turn any of the right on, the right bit will turn on. The speed will turn to 0 for it to turn right, and the left bits will stay on 7. So as we can see here, the left is 7 while the right is 0, so it can turn. And this still works for every all 3 of the bits. So just as long as one of them's on, they're gonna turn. So now we have if the middle, so if one of the middle bits is on, or both of them, then it's gonna be 1. And this is the same as if it was 0. So if I took this and so if I took the leftmost and put it on, then it's still gonna, the left is gonna turn to 0 and the right's still gonna turn to stay at 7. Let's try it with the right. And we get the same result, which is just like our simulation. So that's my controller, and there's also another video of it in action.